Hello, these are the 5.2 notes for advanced geometry. These cover the properties of parallelograms. And just if you remember from your graphic organizer, parallelograms, they're like pictures 1 through 4 at the bottom of this page, like the slanted ones, but also they include rectangles, squares, and rhombi. So anything we're talking about today could be applied to those 3 figures as well. Those 3 figures are just a more specific type of parallelogram. Opposite sides, your properties here, opposite sides are 2 things. By definition of a parallelogram, they're parallel. The top and the bottom are parallel to each other, and the left and the right are parallel to each other. Your opposite sides are also congruent. Opposite angles, so if you're talking like top right, bottom left, the ones that are like diagonally across from each other, those opposite angles are congruent. Your consecutive angles are the ones just like right, if you go around the corner, like the 2 tops, the 2 lefts, the 2 bottoms, the 2 rights. If you think about it as the lines that make up the parallelogram are parallel lines, so any 2 consecutive ones there are also same side interior, so those are supplementary. And then our last rule here is diagonals. Diagonals bisect each other. The diagonals will cut each other in half. All right, so we're just going to take these 5 rules and apply them to the parallelograms in 1 through 4 here. Number 1 talks about angles. So if you look at our list here, we either have consecutive angles are supplementary or opposite angles are congruent. So if you went consecutive, that would be like y and 8x. But those are 2 different variables, so we don't want to do that. Your other option is to go consecutively with the bottom 2. So these 2, they're between 2 parallel lines, so these are like same side interior angles, so they're supplementary. So 7x and 8x should add up to 180. So that's 15 x's all together. So x is 12. If you know x is 12, you can plug that back in. 7 times 12, that's going to give you an angle of 84 degrees here. And then if we apply what we know, you could go either way, but the easier way is to say that opposite angles are congruent. So by number 3 here, this angle would also be 84 degrees. Let's see, number 2. Number 2 is going to have the same ideas here. You have angles, and you could either go consecutively, and then eventually we're going to have to maybe do diagonals. Either way. Let's see here. This one here, this 4x minus 5, and this 2x plus 5, again, these are parallel lines, and here's your transversal, so these ones are same side interior angles. So you could say that 4x minus 5 and 2x plus 5 needs to add up to 180. It's kind of nice, your 5's cancel, and you've got 6 times something is 180, so x is 30. Once you know x is 30, you should go ahead and plug that back in. Think down here, 2 times 30 plus 5, so 65. And then if you're thinking side to side, let me switch colors here. These 2 angles are same side interior as well. It's just between like the more horizontal or vertical lines. So these should also add up to 180. So 2y plus 5 plus 65 equals 180. My pen's dying. Okay, so we've got 2y plus 70 is 180. So 2y is 110. So 1y is 55. If you wanted to, you could have also went diagonally. If you know this is 65, oh, that would have been a lot easier. You could have said that y plus 10 should also be 65. Yeah, we should have done that. That would have been a lot quicker. But now you know both. All right, number 3. Number 3, you have the diagonals labeled. So hopefully you realize we're going to talk about diagonals. So that's property number 5. The diagonals cut each other in half. So this part is equal to that part, and the y is equal to 3x plus 1. This one, you don't know if the diagonals are equal though, and that's a big deal. In some of your figures they are, but in general for parallelograms, you can't say that your diagonals are congruent. And if you look at this picture, hopefully you realize this one here, going downhill, the negative slope diagonal, looks a lot longer than this one. So these 4 segments are not all equal. So unfortunately, we're going to have that y equals 3x plus 1. And we also know that y plus 15 equals 5x. Hopefully by now you realize we have x's and y's mixed in our equations, so we're going to have to do a system. But they're kind of nice at least. It's a nice system. So you can plug it in there. 3x plus 1 plus 15 is 5x. And if you get rid of your 3x and you combine that, 16 is 2x, so 1x is 8. Once you know x is 8, you know that y is 3 times x plus 1, so y is 25. There you go. All right, number 4. Number 4, you have the sides. So this is referring to property number 2. And opposite sides, they're parallel and congruent. So this one and this one are the same, and the top and the bottom are congruent. So this is pretty nice. 3x plus 1 equals 5x minus 1. Bada bing, bada boom, we get x is equal to 1. And then unfortunately for the y's, we can't just plug it in. We do have to solve it separately. So the top is equal to the bottom. So we get 1y equals 7. If you wanted to keep track of these ones, number 1 and number 2, those are also, they're using the same properties, and that's your property number 3 and 4. So both 1 and 2.